Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2022's Combined Science Physics Paper 1 higher tier. This is question number 4, which is on the particle model of matter. A student investigated how the pressure of a gas depends on its temperature. The volume of the gas did not change. Figure 6 shows the equipment used. So they have a mixture of ice and water surrounding a round bottom flask. You call this a round bottom flask, which is sealed. It's got a thermometer, and at the initially the air is going to be cooler here, and it's connected to a pressure meter, so they're going to heat it. Pressure is sometimes measured in units called atmospheres. 1 atmosphere is 10 to the power of 5 pascals. What is 1 atmosphere in kilopascals? Well, 1 atmosphere, if I convert it to just pascals, so 10 to the power 5 is the same as 1 and 5 zeros. That's 100,000 pascals. To convert it to kilopascals, you'll divide it by 1,000, which will give you 100 kilopascals. That's 100 kilopascals. 4.2. The student took 4 pressure readings for each temperature. Table 1 shows the pressure readings when the temperature was 50 degrees Celsius. So you have 4 of these readings. Calculate the uncertainty in the mean pressure. How do you calculate the uncertainty? You find the lowest value, which is this, and you find the highest value, which is that, and you work out the difference. So the highest is 0.121 minus 0.115. The difference would be 0.006. Thus the range between the highest and the lowest value. So the uncertainty is the midpoint between this range. So 0.006, divide that by 2, that gives me 0.003 plus or minus. So they've already given you the plus or minus sign here. So 0.003. Now the value of uncertainties, just to visualize, just a little bit of a note here. So let's say in a graph, you're plotting a points for a line, right? So these points that you're plotting is going to be the mean values for, let's say, 30 degrees, 40 and 50 degrees. So at 50 degrees, the mean value that you plotted is here. So getting values from this, its mean is the midpoint. So if you were to draw a small bar, that would be from the midpoint, it's 0.03 in the negative and in the 0.03 in the positive as well. So that's basically the range for each point. So uncertainties give the range for each of the point where it could actually fall. Question 4.3. Figure 7 shows a sketch graph of the results. So you have pressure in megapascals, and it's a straight line as the temperature increases. The student said, as the temperature increases, the pressure increases. True. Give a better description of the relationship between temperature and pressure. Now, because it's a straight line, you could call it a linear relationship. This is exactly what you need to do. The relationship is linear. If it wasn't a straight line, you could call it non-linear. If it goes from the midpoint like this, so if it went like that, that would be directly proportional. Right? Next part, a pressure cooker is a sealed pot that uses steam to cook food. Figure 8 shows a pressure cooker. So you have the heating element at the bottom, which is going to heat the water in the container here, and you have the platform for the food, and they had to use a broccoli. Okay, so 4.4. When the water in the pressure cooker starts to boil, the amount of steam in the pressure cooker increases. So when it boils, the amount of steam here will actually increase. So if all of these dots were steam or gas molecules, that's going to increase. The temperature of the steam increases above 100 degrees Celsius. Explain why these changes make the pressure in the cooker increase. So why would it increase the pressure? Remember, pressure equals force over area. So we need to start off from the equation. Pressure equals force over the area or the surface area. Now the area is basically the area of the walls of the container. Now that area is not going to change. So for the pressure to increase, the force must have increased. So if you identify, okay, how is the force increasing when this happens? The amount of steam in the pressure increases and the temperature. Well, if you increase the number of particles, if the steam particles increase, right, and if the temperature increases, then the kinetic energy also increases. So here's the answer. As the amount of steam increases, the number of particles increase. And as the temperature increases, the particles move faster, which is kinetic energy increases. Now, when this happens, the particles collide with the walls of the cooker, and these collisions are more frequent, and each collision exerts more force. And pressure depends on the force divided by the surface area. So when force increases, pressure increases. Question 4.5. If the pressure inside the pressure cooker becomes greater than 200 kilopascals, then some of the steam is released through the safety valve. The released steam expands as it moves into the atmosphere. Explain how a change in density of the steam is caused by a change in the arrangement of particles in the steam as it is released. Now, remember, density is mass over volume. Now, if the steam expands, the volume gets bigger. If the volume gets bigger, the mass is the same, the density drops. The particles spread out, so the steam takes up a greater volume. Since density equals mass divided by the volume, the density decreases. That brings us to the end of question number 4. I will see you in question number 5.